Okay, so we want a triangle that has a side of 11 at the bottom. So everybody should have measured 11 units. So I'm going to go quite a ways down on my paper, and I'm going to count 11 units. Let's see if I can see my graph. Can't see that one very well. There it is. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 units. And of course, it's supposed to represent 11 centimeters, but I have 11 units there. Now, I'm going to draw in my side. If you haven't done this yet, make sure you do it. Now, I'm also going to measure 61 degrees. So I want the in-between angle to be 61 degrees right here. I'm going to measure it as carefully as I can because I want it to be truly to scale. This angle, I want it to be 61 degrees. It's going to go through right there. Now for the tricky part. I want this to be 15 units long, and I'm going to use my note card to measure with. So this happens to be 11 units. From right here to here is 11, and I just need 4 more. So 1, 2, 3, 4. This from here to here is 15 units. This was the 11, and then 4 more gave me 15. So I'm going to go from here through that 61 degree mark all the way to 15 units long, and I'll draw in my side. Haley, you're not going to do this today? This is 11 centimeters. This is 15 centimeters. It's supposed to be centimeters. It's obviously these aren't centimeters. Centimeters wouldn't fit on my paper. This is 61 degrees. I measured it. And now what I can do is I can just simply measure my other angles and sides and find what I was missing. So if I want to know what the other side of this triangle is, I can just simply measure it. Look, not using this. I'm just going to draw my line in first. Let me draw in my line here. But let's measure that. You guys measure yours. See what you get for this side. I want to know how long is this side, because that's the X, right? On the board up there. So let's find out how long this is. I'm going to just mark it in red from here to here, and I want to measure how many units it is on my graph paper. So I just have to go to a place where I can see the units pretty well. I could go here because I have 11 already measured out, but I want to get it a little bit closer. Let me see if I can get it a little better here. Let me see. Mark it all the way to the edge so I can see it better. There we go, right there. I want to go from here to here. I like this one better because I know this is 11. This is 11 to here. 12, 13, and a little more than a half. It looks like about 13.6 or 13.7. See what you guys get. I got about 13.6 for this side. Huh? Oh, it could be. It should be pretty close to 13.6 though. Hopefully this is 11, this is 15, this ends up being 13.6 with this angle. Now I'm going to measure this angle too. So measure your angle down here in the corner here. We're going to check what this angle is. By the way, at this point, I could use law of sines to find the angle, right? If I know what this side is. But I'm just measuring, so I'm just going to measure it. Eric, you already drew this? And you're measuring it? All right. Looks like 74 degrees. This is 75 right here. It looks like I'm at 74 degrees right there. And I'm going to measure my top angle. I kind of like it right here. Let's see what it is. There's my protractor. Looks like about 45, huh? Almost exactly 45. Check and see what yours is. Now, this is question number 2 in your worksheet. And what they want you to do is if you're given a side, an angle between them, and a side, you can use what's called the law of cosines to solve this kind of triangle. Now, I used just a scale drawing to estimate my sides and my angles. But here's what you can do. I'm going to call this A because it's my smallest angle. I'm going to call this angle B, and I'm going to call this angle C. Like I told you before, I generally go in order of size. So A is my smallest angle, B is my middle angle, C is my biggest side, biggest angle. Angle C, which is the biggest angle, is across from the biggest side, and we call it little c because it goes with this angle. My smallest side is across from angle A. This is going to be little a. Little a represents the length of this side. And of course, this is across from angle B, so this is little b. Now here's the good news. You don't have to draw things to scale and estimate them. We can get the exact answer if we know these 3 things. A, C, and angle B. I can find everything else on the triangle. What I'm going to start with is little b right here. And remember, these are my estimates. I'm not going to actually use them for this part. We're going to use what's called the law of cosines. It says b squared. I'm going to always start with the opposite side. Now it looks a whole lot like Pythagorean theorem. Take a guess. What's next? A squared. What do you think? Plus c squared. And now this is where it changes just a little bit. There's a little extra here. Minus 2ac cosine, and it's always this one, b. Oh, sorry, I was out of my, there it is. B squared equals a squared plus c squared minus 2ac cosine b. And notice, I have a, I have c, and I have big angle b. So I have everything I need to substitute on this side. Let's substitute it. A is 11. Do it with me. C is 15. A is 11. C is 15. And it's cosine of B, which is 61. I have everything I need to solve this equation. $11 squared? 121. Do you guys remember 15 squared? 225. I think of it as my second 25. My first 25 is 5 squared, and then my second 25 is 15 squared. Now what I do on this one is I multiply it out of order. I do the 2 times 15 first. 30 times 11 is 330. Now I'm going to show you a really big error next. Be careful. We can add these together, no problem. So 121 and 225 makes 336, 346, sorry. What you are going to be very tempted to do, and everybody's tempted to do this on law of cosines. Everybody see this 346 minus 330? Everybody wants to subtract those. You can't do that because this is being multiplied. Multiplication comes before subtraction. Be very careful. Just use your calculator for this last part here. So b squared equals, we're going to put all this in your calculator. I've got 346 minus 330, whoops, missed my minus, cosine of 61. So put those in there. It's nice that your calculator does the work for you. Now, if you didn't have one of these kind of calculators, you would probably have to do this multiplication separately and then subtract it later. But it does all the work for you, and we get about 186. And am I done? One last thing. What's the last part? Square root of both sides. We do have to take the square root of 186. And it's between 169 and 196. It's pretty close to the middle. So I'm guessing about 13.5. But calculator will do it for us. A lot of people are having trouble finding their square root on this calculator. It happens to be right here. It's above the x squared key. Can y'all see it in blue there? I don't know if y'all can see it. It's above the x squared key in blue. So we hit second x squared key, and then we put in the 186. I get about 13.6. Now, you might think it might be easier to scale model it and just measure it, but this is going to be accurate out to here if the 11 and the 15 are accurate. Everybody follow what I mean? If my 11 is like 11.000 and my 15 is 15.000, this is accurate all the way out to here. So we want to be accurate. How many people remember drawing triangles with side construction? You guys remember using your compass to draw the triangles? Because for number one, they gave us a triangle with sides 6 meters, 9 meters, and 13 meters. Obviously, we can't draw them that big. So what I'm going to do, I am going to use my compass and make a scale drawing for this using construction. It's really the only way to go. So I'm going to start with 13 units long to start with. Right here, I'm going to start, I'm going to make it 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There it is, right there. Okay. This segment is 13 units long. I'm gonna label it 13 meters, but obviously it's not. I probably get 13 millimeters out of it. All right, there we go. There's 13 meters, or 13 units. Now the trick is, I'm going to use my compass to measure the arcs for my other two sides. Now I want a side that's 6 meters, and I want a side that's 9 meters, or 6 units and 9 units. So what I'm going to do is I'm going to count 6 units out. Count out 6 units. So there's 6 units, and I'm going to make an arc that's 6 units long. I'm going to use my compass, and I want it to go right through that point right there. And I want to make an arc that's 6 units long, just like this. I know that this side is somewhere here. Somewhere on this arc is a side that's 6 units long. Draw yours. Can you all see that this is 6, and then it's 6 everywhere on here? Now I want the other side to be 9. So I'm going to measure 9 units from this side over here. So I'm going to count out 9. Count out 9 from here. This is going to be 1, 2. Oh, I can't see it very well. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 units apart right there. From here to here is 9 units. And what I'm going to do is draw an arc 9 units long. And what's going to happen is this is going to be for this intersection right here. Can everybody see this is 6 units because it's on this arc? See this? 6 units right here. 9 units because it's on this arc. So I can draw in my triangle. One of them is here. And one of them is here. So this is 6 meters, 13 meters, and 9 meters over here. Now what I could do is I could measure this angle right here, because they may want to know one of the angles. And this is the angle that I want to know. Now, if I want to know what this angle is, I could measure it since I drew this to scale. But we're going to go ahead and use our law of cosines. And I'm going to put my biggest angle, I'm going to call it C. And of course, this is little c. I generally use my smallest one as A. And so this is little a. And this is my B. And this is my little b. Go ahead and label your sides. And what we're going to do is we're going to use law of cosines to find this missing angle. So I'm going to start with c squared. I want this angle, so I start with this side, which is across from the angle. So I start with c squared. Now, based on your pattern, what do you think comes next? A squared plus b squared minus 2ab, because it's always these two, see them? Cosine, and the only thing missing is the big C. Notice that this equation is different than the one up above, but it has the same pattern. They follow the same pattern. There's 3 different ones. Now this time it's a little different because we do have C, don't we? See how it's different? We've got the C, which is 13. We have the A, which is 6. Bear with me, guys. I know it's a long lesson. I'm especially aware of it. Remember, I have to do this 5 times. You guys only have to do it once. But I think it's worthwhile. B is 9. Minus 2. A is 6. B is 9. And the thing we don't know is the cosine C. You guys remember 13 squared? 169, yeah. By the way, 14 squared, they just turn around, 196. 6 squared is 36. 9 squared? 81. 2 times 6 is 12, times 9 is 108. Cosine C. And we're getting there. You need to do the addition here. You have to simplify. This is 117 minus 108 cosine C. Now, you're going to be very tempted to want to subtract these. You can't subtract them. You got to be careful. This is very tempting, that subtraction right there. Remember, it's being multiplied by the cosine C, so you can't subtract. I can subtract 117 from both sides, though, because I want to get cosine C by itself. Subtract that 117 from both sides. And we get my fifth favorite number, 52. Negative 108. We're almost done. Cosine C. Only two more steps. Divide by the negative 108. Be careful on your calculator. Make sure you use the negative key. The negative key is below your numbers. You can't use the subtraction because it'll give you a syntax error. So I'm going to take 52. Let me write it in here for you. Divided by, and this is your negative key down here. It's on your number pad. 108. And you get a decimal. Negative 0.48. Cosine C then is equal to negative 0.4815, approximately. This is one of the few places where you really can't use a table. Your table only goes 0 to 90 degree angles, right? Can everybody see this is bigger than 90? That's how we ended up with a negative cosine. What we're going to do is just take the inverse cosine of both sides, arc cosine if you like. You can call it either one, and they're both correct. I kind of like arc cosine. It's kind of cool sound. Crosses that out, and we take the arc cosine of that decimal right there. So I want inverse cosine. Looks like that. Has a little negative 1 up in the corner. And then I put in my decimal, negative 0.48148. I could put some more, but that's fine. I get approximately 119 degrees. 118.8 is on your worksheet, so we'll do it that way. (118.8 degrees). I'm going to go ahead and measure it. Now the problem is when you, bless you, when you measure these little triangles, if the triangle's too small and it doesn't reach your measuring, you see how it doesn't reach the scale up here? You just extend one of the sides out a little bit. So I'm going to turn this around to make it easier to measure with. And then I'm also going to extend one of the sides. It just makes it possible to read it a little easier. Extend it out. I'll just extend out that side a little bit. And I'm going to measure this angle. Let's see what I get. I should get something close to 118. I actually get 116 on this one. I keep getting 116 on mine. See if yours is closer than mine. Anybody get closer? 119 it should be. I got 116 this time and 116 last time. It's probably because I'm not being real careful with my arcs here. And I didn't sharpen my pencil, and I wasn't really, I was having a little trouble seeing my units on there. You guys have two problems, number 3 and 4. I recommend that you start with number 4. Do it on the back of your paper. You only have 2 problems to do, so get those done.